Thank you.
Thank you. And thank you for the introduction. And thank you also for Velux for inviting me and putting together this event here. It's really nice to be here today. And what I'll talk about is, I'm not an architect or a designer, but I'm a sort of technical person who would like to develop tools to help lighting designers and architects. And I'll talk about two different tools today that we've been working on in Luxion. And you may have heard about Luxion. It's a small company. It started by myself and my brother, Klaus, and we specialize in simulating light transport efficiently. I'll talk about two software tools today. One is the Velux Daylight Visualizer, and another one is called KeyShot. These are two quite different tools that share sort of some common engine in the way they simulate the lighting. The Velux Daylight Visualizer is a tool that we've been developing for Velux over the past 10 years. And I'll show you sort of some of the new things that are coming out in the Daylight Visualizer. KeyShot is a separate program. I'll show you the two, and I'll also show you how we are now working on enabling them to work together and how that may benefit you, and maybe get some feedback from you on if this could be useful. The Velux Daylight Visualizer, I don't know if you tried it yet. Highly recommend trying it. It's a fairly mature program. It's available at viz.velux.com. It's a free download. And what it does is enables you to simulate daylighting in buildings. It has a very easy-to-use interface. We wanted it to make not intimidating, so this is not a complex software tool where you need to know all kinds of rendering parameters to use it. So we use a sophisticated engine under the hood, which means all you have to say is simulate the daylight. It will do the rest for you. You can get your geometry into it in different ways. If you tried the Daylight Visualizer in the first version that came out several years ago, you could only build very simple houses. Since then, we've improved it, and now you can import models from a number of CAD systems and get that in and perform the simulation on that. It also has a database of Velux windows, so Velux does have an incentive to promote this tool. And what you can do in it is you can do a number of standard simulations, such as luminance, illuminance, compute daylight factors. We also are looking at sort of enhancing that in different ways. There's been some discussion today whether daylight factors is the right way of doing it, but that's what we do for now. You can do some annual overviews, cross-sections, and false color renderings, work plane simulations. We have all the standard CRE skies. There are 16 types, from cloudy to clear and intermediate types. And one thing we have that's unique is we actually took the effort and spent over a year to validate the engine against the CRE. They have a number of test cases that they said these are hard test cases that if you can sort of be validated against them, you actually compute lighting correctly. So we made the effort and did that. And as far as I know, it's still the only lighting engine that's been verified against these CRE test cases. Here's an example of the output, and this is actually the Velux Visualizer 2.0 or 2.5 that you can download today. What you see on the left is just an example of a rendering output of the visualizer of a building lit under a daylit or normal sky. And on the right, it's actually a photograph of the space that was later built. So you can see with this tool, even though it's free, you're actually able to get very nice results that sort of matches the real-world lighting fairly nicely. And then, of course, you can do additional things, such as do analysis of the lighting that falls in the space. In this case, illuminance visualizations, and you can do a cross-section where you can see the lighting in the room. You can play with it in different ways. You can play with the materials, you can play with the window configuration, and so on to see how do you get the good lighting in the space. Now, KeyShot is a slightly different program. KeyShot is not really in its current form, or has not until today been intended for sort of architects and lighting designers, but rather for industrial designers, so people that make products. So it's a program, again, makes the process of making photographic images of CAD data, 3D models, very simple. The interface of KeyShot is likewise fairly simple. You import your data, we have a library of materials and lighting, you apply that, and then you make a picture. And again, we try to make it fairly simple. So again, sophisticated technology under the hood to make a final output that's high quality, but a simple process to get there. KeyShot can import lots of different formats, so you can get data from pretty much any CAD system you have out there. It is also integrated with quite a number of CAD systems, where you can go in the CAD system, you can push your data straight to KeyShot. It has a number of materials. We actually have what we call scientifically accurate materials. We've actually worked with a number of vendors that have measured materials. Some of these are more for products. So we have, for example, automotive paints. So DuPont, before they got spun off to Axalta, had a lot of paints that they actually measured, so automotive paints. And we're the only ones that have been able to go in and match the measured data. We can take in the measurements of their paints and visualize that accurately in KeyShot, so you know that the rendering you get on the screen matches the paint that you put on the car. And we have a number of other materials in a big library with over 1,000 materials. And in addition, we, of course, have custom materials. We go in and control it based on measurements. So if you have a meter that can measure glass, for example, you can input that directly in KeyShot and get an accurate visualization of that material as well. Colors is important for industrial design. I don't know how much it's used in architecture, but we do have lots of colors in there, Pantone, RAL, CAE Lab, so different color spaces you can use. And that makes it easy to adhere to a standard. You can also use ICC profiles to guarantee that what you see on the monitor matches the color that you put on the product. So it actually will look like that in the real world as well. And in terms of lighting, KeyShot is a little different than the visualizer. The visualizer uses sort of standardized daylighting, so you can do lighting analysis based on these CRE skies. In KeyShot, you can do a number of different things. You could use the CRE skies, but you can also use what's popular for industrial design. You could use a photograph of real-world lighting, so-called high dynamic range image, where you take a sphere of light, like an environment, capture that in a photograph, and you can use that to illuminate your products. You can also create skylights. We have a spectral skylight model. It actually simulates the sun location. You get full color for the skylight, and then you can use sort of standard IS lights, local lighting. One unique thing in KeyShot is it's highly optimized. So you actually have a real-time visualization of the lighting. And again, we use the same rendering engine under the hood, so it's been verified against these CAE test cases to compute the lighting correctly. What you see on the right is just a little specialized. It's a caustic simulation where you have a beam of light coming in, hitting a prism, and it's reflecting inside a cylinder. And there's just one of our users who's a lighting expert who wanted to test really extreme lighting conditions with dispersion and reflections and so on, the light focused through glass. Lots of customers to use KeyShot. Not a lot of architects right now. We do have Fosters and partners in the list, but right now it's not set up really for interior lighting, it's set up for product lighting. But that's something that we're changing, and one of the things I wanted to show you today as well. And here's another example of a product, Microsoft Surface. Many of the customers, if you see products from them and you see marketing or you see an image on the box, you may think it's a photograph, but really no one uses photography anymore. It's all computer graphics, and most of the images are created with KeyShot. This is an output of KeyShot, and the Microsoft marketing campaign was all done using KeyShot. Here's another example. It's a Chrysler. If you go to their website, look at the images of the cars. Most of the images on their website have been created, again, in KeyShot. And even if you take something as mundane as an IKEA catalog today, 90% of the images in there, even of a living room, it's all computer graphics. Here's just another one. This picture here, I just wanted to show because it actually has a left half and a right half. There's a line going down the middle, and one side is a photograph, and the other side is a rendered in KeyShot. So just to show how we can match the human skin as well accurately. I know it's not as interesting maybe for architecture, but if you want to have translucent materials with high accuracy, it's one of the things that can be important. I won't say which side. I'll let that be up to you to figure that out. So we had these two software tools. So what is new and what has been happening that makes it interesting to talk about, and what's interesting from a daylight perspective. So a few years ago, Velux was saying that the daylight visualizer, it's really nice. You put in the windows, it simulates the lighting, and we like that. But we had these products called sun tunnels or light pipes, where you take a pipe, you guide light into the space, and they wanted to include that. And we scratched our heads and said, that's a little difficult, getting the light to go into a space from outside through these pipes. It's actually not easy. There aren't really any algorithms available that will do that. So we started thinking about it, and on my research side, I was fortunate to work with some really smart people. And we looked at this equation. This equation is actually shared between the Daylight Visualizer and actually all software that compute lighting solve this equation. I'm not going to talk about it for a long time, just say what it describes is light at a point is equal to the light that's emitted at a point plus light reflected from all other points in the scene. Relatively simple, but complex to compute. So I worked with some smart people, and we developed a technique called stochastic progressive photon mapping. It's a bidirectional technique. You shoot photons from the light, you shoot rays in from the camera, you gather them in the middle, use some techniques to make them able to find each other a little faster. And if you optimize that enough, you actually get an algorithm you can use to compute these lighting in these more complex scenarios. Here's sort of a specialized case, just to show we compared against other state-of-the-art algorithms. Some of you may have, if you played with rendering software, you may have noticed if you take a real light source, a filament, put it inside a lamp, and say, I'm going to do a perfect simulation of this space, your rendering software will completely fail and won't give you anything. You need this IS light, you need a box that's glowing. But if you make a real light source, it won't work. And that's because a lot of the technology that's been developed has these simplifying assumptions that you have to be able to see the light source. And so we developed this algorithm where the first test case we did was this simple lamp. And we put a small filament inside of it. And all the existing algorithms, path tracing, bidirectional path tracing, metropolis light transport, all failed at capturing that. And they're considered, so to say, state-of-the-art. But the new algorithm can actually do that. Don't worry about the hours below. We have optimized it quite a bit. I'll show you some examples of that as well. So what we did was we received this model from Velux. They said, here's a box. It's all closed. We put 8 pipes in it, sun tunnels. We want to simulate the lighting inside this box. And the other algorithms, when we tried them, just failed miserably, and it was very noisy. So this was the test case they gave us. And you're inside, and of course the challenge is you want to bring the daylight from outside inside this space through these sun tunnels, these cylinders. And I'm going to take a chance today and show you a demo of how that works using the Daylight Visualizer 3.0, which is still in beta. So here's the model, and here's the sun tunnel. The Daylight Visualizer, just to show you, it's very simple. You set up your surfaces on the model. You specify the location. You set it to London. You can set your camera where you want it to point. And then in render, you can do different types of simulations. You can do cross-section, still image, luminance, and so on. And I just do a low-quality render just to show with this scene that's actually fairly complicated. And now you can actually get an idea of it pretty quickly. And this is, again, a 2-year-old laptop with 4 cores, so not state-of-the-art, really. But you can fairly quickly get an idea of the lighting in the scene. Of course, you let it run long enough. The idea here, this algorithm is actually what's called a progressive algorithm. So you start it, you get feedback right away. You can see, is the light in the space? What's the rough shape? You let it sit for some time. It will refine and give you, it'll converge to a correct result. Sorry? It's not visualized correctly here for some reason. I got a build last night that had some things with it. But let me show you. So this is sort of a rough image you can get. Of course, here you can do all kinds of things. You can do false color and so on, and analyze it in different ways. What you can also do now is we can start KeyShot, if you have that. And then we can go back to the visualizer and say, take this data, and then just send it to KeyShot. And KeyShot is going to pop up. And it's going to receive the model. And it's a full model that I think Nicholas actually made. So it's fairly complicated. It has a lot of detail in it. He wanted to make sure this algorithm is not just for simple setup. So it has, I think, 1.5 million polygons. And just so you can see that these pipes, the complexity of it, if I hide the model here, you see these pipes are relatively long, so getting the light to actually bounce around inside the metallic pipes is a little tricky. So now that we're in KeyShot, what can we do here? Well, I can go take the lighting environment. You can see it's just this is mainly for product design. It's a simple, smooth lighting. It's not based on anything realistic. But I did a few years ago. I went to Utah and I took a photo of a Kodachrome basin. So you can put the lighting here. Now, of course, if you really wanted to place this correctly, you'd have to scale and everything to place it in the space. I don't really care about the scale here. It's not that I'm putting a building in a photograph or in an environment. If you did that, you can do that, all kinds of tools to match that. I just care about the lighting that's inside this building now. So what I can do next is I can go inside, take the camera inside. Now it's very dark because there's really not a lot of light coming inside. We can try to brighten it a little bit. Let's say make it 20 times brighter. It's still pretty dark. Now what happens is that, of course, you have the walls are casting shadows here. If I turn off the shadows, okay, let's see it. Turn it down again. You can see we are inside the room here. So if I turn on the shadows again, now what I need is I need to simulate all the light bouncing around inside the model. That's what's called global illumination. If I turn that on, if I crank up the intensity a little bit, and then we need lots of bounces here. So put this up high. Now this is the old algorithm. This is if you would try to do this with an old algorithm. You get something that would be quite noisy. So if we turn on the new algorithm that we developed for Velux to simulate these products, you get something much faster. And again, it's running on a laptop, and this one is not as fast as it could be because we actually use also some pretty sophisticated things. The sun tunnel is all metallic inside, and then there's a diffuser on the front, but it's not a simple diffuser. We actually, Velux again wanted it to be accurate, so we did a measurement of the actual diffuser material. So it's actually a full measurement in a gonio reflectometer of the light scattering by the diffuser. It makes it a little bit slower to deal with. You may wonder, why do you want to put this in KeyShot if you have it in a visualizer? And maybe you don't need that. This is more if you want to go, say you want to go in and do some design. So now you can drop some materials in. You do bathroom tiles. It's going to recompute fairly quickly, and then you can move around. If you want, you can sort of move a little bit forward here and navigate, and you can change the lighting. You can do different things inside this. So what we're doing now is we're taking KeyShot, we're adding capabilities for you to walk around in the space and also have this sophisticated daylighting, bring it into a model, and you can really combine it with any kind of electrical lighting, daylighting here, and so on. These two programs are still in beta, so but they'll be released shortly. So here's what it looks like, the sun tunnel with a measured diffuser material. You may wonder, why do you want to use a measured material? What's the benefit of doing that? We actually had one of our guys try to match the material as accurately as he could. So he used a glossy frosted glass, but you can see the shape of the lighting is not quite right. So to really capture what comes out of the sun tunnel, it's important to have these measured materials. Of course, you can now do the illuminance as well, visualizations, and assess the lighting from the sun tunnels. You can use the live link to go to KeyShot, and you get the same image because it is the same computation under the hood. But then in KeyShot, you can play with materials. You can make it a little bit more blue. You can change it in different ways, put different colors in, wood floors, and so on. And this, of course, sort of comes then. I guess you'd have to go back and do the lighting simulation again if you change the materials too much, because, of course, it all works together. And then here's just an example where we asked, what if you don't rely on the sun tunnel, but you rely on electrical lighting? So we use some standard IS lights up here instead. So you can just play with that, have different types of lighting in the scene. And then you can use it, of course, for other architectural spaces as well. So, and here's another little model. So this was just a little overview of some of the things. So feel free to come with some feedback and say, is this useful to you? The Daylight Visualizer 3, hopefully it's available later this year, within a few weeks. And then again, you can still download that for free. KeyShot is not free, but you'll make us happy if you acquire a copy of it. And other than that, thank you very much.